So today we shall be doing the unit root testing, and you can see there is a one variable which is y, and the data is from 1970 to 1995, meaning that there are 26 observations, and here is the data y. So it is the only variable in this model. So I'd like to open the y variables. So you can see the y variable here, right? It starts from 1970 to 1995. So this is the y variable from 1970 to 1995. Okay, so today we shall be checking whether this variable, which is y, so is this variable got unit root or not? In other way, whether this y variable has unit root or not, that we shall be checking today. Okay, so you can see from here. So we shall be doing, as I told, unit root testing. So how to test it? So here is a augmented Dickey-Fuller test. So here we have one method, and the method is called augmented Dickey-Fuller test. So this test can tell us whether a particular variable got unit root or not. And this augmented Dickey-Fuller test has three shapes. So the first shape is this one, that is the first shape. That means that is equation 1. So this the first shape has only intercept only. You see here is only intercept. And the second shape of the augmented Dickey-Fuller test is that it has only trend and intercept. You can see from here, you can see the trend, which is t, and intercept. And the third shape of the Dickey-Fuller test is this one. So it is equation number 3, meaning that it has no trend and no intercept. That you can see from here. Here is no trend or no intercept in this equation number 3. So augmented Dickey-Fuller has three shapes. So all the tests I shall be checking using EVIEWS. Okay, and what is the null hypothesis? Sorry, what is the hypothesis setting? What is the null hypothesis? Variable is not stationary or got unit root. That is the null hypothesis. And what is alternative? The variable is stationary. So that is null and alternative. And what happens when the p-value is less than 5%? Then we reject null, meaning that the particular variable is stationary. But if the p-value is more than 5%, meaning that we cannot reject null, meaning that we accept null. So it means that that particular variable got unit root, or the variable is not stationary. And now we shall be checking all the three models here. This is the model number 1, model number 2, and model number 3. All we shall be checking now. One by one we shall be checking using augmented diffuller test. Okay, and this is our variable. We want to check whether this variable has unit root or not. That we want to check. And so first I click on the quick, then I click on the series statistics, then click on the unit root test. That you can see from here. I'm clicking on it. Okay, what is the name of the series? Here is y. Y is our variable that we want to test, whether this variable has unit root or not. So then I press OK. Okay, here you can see augmented diffuller is given by default, right? So it is already here, and the lags length, that means this augmented diffuller must have lag length. So that means it can be lag 1, it can be lag 2, it can be lag 3. So we suggest automatic selection, right? That means the software will decide how many lags should be there. So automatic selection, and I choose short information criteria. You see there are many criteria. Suppose I choose this one. So according to the software, she had chosen maximum 5 lakhs. Okay, now I talk about this part and talk about this part. Okay, first I talk about this part. As I told you just right now, augmented diffuller has 3 shapes. First shape got intercept, that is equation number 1, and second shape is trend and intercept, and third shape, that augmented diffuller has neither intercept nor trend. So all the three, suppose we want to take a decisions about a particular variable, then all these 3 must agree. If one disagree, then we cannot take the decision. So all 3 must agree about a particular variable, whether this particular variable has unit root or not. And here are the few steps. One is label the data at the label form, and this one is the data in the first difference, and this one is the data in the second difference. Okay, first I check with the label. Then if it is not at label, and we check the status, that whether our variable, which is y, has got unit root or not. So we check it in the label. What does mean by label? Label means at the initial data, that means the raw data that I am using now. Okay, so I choose that label and I choose this one, intercept, right? Then I run the model. I press OK. Okay, the result has come up. So what is the result? What is null hypothesis? Y has a unit root. That is the null. And the first one is just constant. What is constant? It has only intercept, so that is called constant. And this is the augmented Dickey-Fuller test statistics, and it is p-value. Okay, so what is the p-value? 6.89%, which is more than 5%, meaning that we cannot reject null. That means what we cannot reject this one, null hypothesis, meaning that y has a unique root. Okay, that is the one way. And there is another way. It is here. Another way we can take decision whether y has a unique root or not. This is the way you can check. This is the test statistics, right? And these are all critical value at 1% level, 5% level, and 10% level. So these are the critical values. Okay, and what is the guideline? Guideline says that if the test statistics is more than critical value, we can reject null. That is the standard procedures. If the test statistics, the value of the test statistics is more than critical value, we can reject null. But if the test statistics is less than critical value, we cannot reject null, meaning that we accept null. So that is the guidelines. Okay, so from this guideline, we choose only absolute value. You know what does mean by absolute value? Absolute value, as I told, there is no negative sign. That means no sign is there. So that means no negative sign. So meaning that 2.80 is smaller than this one, smaller than this one. So, but not smaller than this one, of course, right? But normally we take 1% and 5%. Normally we do not accept 10% level, normally. So now this test statistics is less than this one and less than this one, meaning that we cannot reject null, meaning that we accept null hypothesis, that is y has a unique root. And the probability concept also given the same decision that y has a unique root. Okay, but one thing, make sure the coefficient. Okay, what is this part? This part actually augmented Dickey-Fuller test model, right? And this model has only intercept, as I told, right? You see, the model has only intercept. So, and make sure the coefficient of this variable should be negative, right? Here must be negative, otherwise the model will not be viable. Otherwise we cannot accept these models. So here it is negative. So the decision we have taken about y variable is all right. Okay, so this one is the first one. What about now second one that we can do again? As before, we go to quick series statistics and unit to test. I put y, then I check, and okay, last time I choose intercept. Now I choose this one, the second phase, second shape of the augmented diffuller test, and the second shape got trained and intercept, and I am doing it under level. Then I press OK. So you can see here, null hypothesis, y has a unit root, so it has constant and train, both it has. And you can see the probability value, how much? 10.38%. It means what? It is more than 5%. So we cannot reject null. We accept null hypothesis, meaning that y has a unit root. Okay, that is one approach. So what is the second approach? If the test statistics is more than critical value, we can also reject null, right? That is the second approach. So this value, absolute value of this one is smaller than this one, smaller than this one, and also smaller than this one, meaning that we cannot reject null, meaning that we accept null. So y has a unit root. So the probability approach and t-statistics approach is telling the same decision that y has a unit root. And we come here, it is the augmented diffuller, right? Equation, it is the equation, right? But make sure the coefficient of this variable should be negative. This should be negative. Otherwise, this calculation is not valid, or the model is not valid. So it is negative, so we are happy about the model. Okay, so we have done the second one. Now we check the third one. Series statistics, unit root test. I put y, then okay. Okay, intercept we checked, trend and intercept we checked. Now we check the none. None means the model does not have any intercept or any trend. That is none. And we are doing it in the label form as before. Now click on the OK. So you see the outcome, null hypothesis, y has a unit root and there is a none. Okay, now from here the probability value or the p-value 11.15%, meaning that it is more than 5%. We cannot reject null. That means y has a unit root. And what about here? Absolute value of the test statistics is smaller than this, and smaller than this, meaning that we cannot reject null. So y has a unit root. And what about the model? Augmented diffuller model having none. You see here is none, right? No intercept or no trend. But the coefficient value is negative. So the model is alright and viable. Okay, so what is our decisions? What is our decision? Okay, so our decision that at level this model, and this model, three model of augmented diffuller test is telling that y has a unit root. So what does mean by unit root? the variable is not stationary.